Hello everyone, welcome to lesson 63 of our GoLang course. In this lesson, we will continue the exploration of net/HTTP package and look at creating an HTTP server. Before diving into the code, let us understand the basic types and functions available through the package for use to start building our HTTP server. First, we have the listen and serve function. The net/HTTP package provides the function listen and serve to start a HTTP server. Here, we have the signature for listen and serve function. Listen and serve takes an array string to listen on or start the server on and a handler to handle the incoming request. It will use the default serve mux if the provided handler is nil. We will talk serve mux in the next lesson. For our development purposes, we will use localhost server, that is, a server running on localhost or on our machine. As such, we will provide an address of :8080, which stands for listen on localhost port 8080. Now let us look at the http.handler. The handler here is an interface with one method called serve HTTP. It takes a response writer and a pointer to request. The handler responds to a HTTP request and handles the incoming request for the server. There are some basic rules of request handling in Go. Let us go over them. First is, the handler should write reply headers and data to response writer and then return. Returning from a handler signals that the request is finished or the request processing is finished. It is not valid to write to the response writer or read from the request body after the request has been completed. It is a good habit to read from the request first before writing a response. Doing otherwise may cause bugs or panic. The handler should only use the request to read data from it and should not modify the request. Please note that if you panic inside the handler, the server assumes that the panic was isolated and logs a stack trace to the server logs and closes a connection. So there's a sentinel error provided by the HTTP package called error abort handler. Panicking with error abort handler will make the client see the interrupted response and make the server not log the error. Now let us cover the http.responseWriter interface. The response writer interface is used by HTTP handler to construct the HTTP response. Here we have the response writer interface, which has three methods: header, write, and write header. The method header returns a header map that is set on the response. The write method on the response writer is used to write data to the connection as part of HTTP reply. Please note that if you haven't written any header, write calls the write header method with http.statusOK before writing the data. That means by default, the response status will be HTTP OK or 200 if you don't call the write method to write data, or if you don't explicitly set the response header with the write header method. This is where write header comes into play. The write header method sends a HTTP status response header with the provided status code. If write header is not called explicitly, the first call to write or the write method will trigger implicit write header with http.statusOK as we discussed earlier. Thus, explicit calls to write header are mainly used to send error code or HTTP status code in the 100 range. Please note that the status provided to write header should be a valid HTTP status, that is between 100 and less than 600 range. Now let us shift our attention to the HTTP request type. The HTTP request struct represents an HTTP request received by a server or sent by a client as seen in the last lesson. Please note that we won't go into details of each field in the request structure, but only cover the ones that can get us going. The field method of type string specify the HTTP method, that is get, post, put, etc. for client request, where an empty string means that it was a GET request. So you can access the method field on request and know which HTTP method was used. Next, we have the URL. The URL specifies either the URI being requested when used on the server side or the URL to access when used on the client side. So this is basically the server URL you are trying to access. Header is a field of type map string and then a slice of string, that is Key is a string and value is a slice of string. It contains the request header either received by the server or sent by the client. So you can use it on the server side to access headers set by the client or on the client side to set headers like the authorization header. Request also has a field called body, which is of type io.readCloser. For a client request, a nil body means that a request has no body, such as for a GET request as we saw in the last lesson. For a server request, the request body is always non-nil but will return end of file immediately when no body is present, or for GET request as an example. The server will close the body of the request. That is, in your handler method, serve HTTP, you don't have to worry about closing the request body. The server will do it for you. Then we have the form, which is of type url.value and contains the parse form data, including both the URL field's query parameters and patch, post, or put form data. The field is only available after the method parse form is called on the request. With this knowledge, let us create our first HTTP server. So let us start the server by calling the listen and serve function, which returns an error if there was an error starting the server. So start the server with listen and serve, pass the addressing. For localhost port 8080, we can just do :8080. And if error is not equal to nil, we will print the error to the console. As you can see, the first is the address string. The second is a handler. So let us create a handler. I'm just going to create a hello handler, which is a struct with no fields, and then we can implement our serve HTTP method to comply with the handler interface. It accepts a http.response-writer and pointer to http.request. So request here represents the incoming request, and response-writer can be used to formulate the response data. So we will use the write method to send byte data. For our example, we will just say hello. Since our struct implements the serve HTTP method, it complies with the handler interface. As such, we can do new hello handler, and that works. Let us now run our program to verify if our server is working. So you don't see any error. That means our server is working. In a different terminal, we can just make request to localhost 8080 and see if it works. So I'm just making a request with curl. This is a GET request. Let us see what we get. And as you can see, we are getting the hello response. Now what happens if I made a POST request? And as you can see, we are still getting the same response. That is because currently our setup is not able to distinguish between a GET or POST request. And what happens if I append a path? You're still getting hello in the response. That is because we haven't configured any path and specific handler for it. So this handler that we have here is just a global handler. That is, it will serve all the requests. Now, as I told you in the lesson, if I don't provide a handler here and specify nil, that means Go will use a default serve mux, which is a router. Let's restart our server and then try to make the call again. And as you can see, we are getting 404 page not found. That is because we haven't initialized our handler. Since Go will use a default serve mux, what we can do is call http.handle, which takes a pattern for the path and a handler. So if we do hello and then new hello handler, this means that for this path, this handler will be evoked. So let's restart our server and then try again. This time we are still getting 404 page not found. That is because the handler will only handle request for /hello path. So if I try to do curl /hello, you can see we are getting the hello response. But there's another problem. That is, if we still make a GET request, we are still getting hello. That is something that we don't want. We want each method and path combination to have its own handler, and that is where serve mux will come into play, which we are going to look at in the next lesson. Another thing I wanted to show you was that you don't have to create the handler like this, that is, by implementing the method. There's another clever option that Go gives you to create a handler on the go, which is the handler func. So if I do http.handlerfunc, and we can just copy this and put here, then we can get rid of hello handler and this will still work. So let us try that. First, let us restart our server, Try again, curl, and as you can see, it is still working. This happens because HTTP handler func is a wrapper. That is, we can use the first class support for functions to implement the type. Here, we say that any function that accepts a response writer and a request will be of type handler function. Then on the new handler function type, we implement the serve HTTP with response writer and request, and inside it, we just call that function, which is the handler function itself. In this way, you can configure or write handler function on the go and don't have to implement the handler interface. That's it for this lesson. Let us summarize everything we have learned in this lesson. As we saw, the net/http package provides a listen and serve function to start a HTTP server on a given address with a provided handler. And as we saw, handlers are used to serve requests. That's it for the lesson. I hope you enjoyed it. If you have any questions, please feel free to ask in the comments under the video or reach out to our Discord server. Until next time, happy coding.